The 110 kV gas-insulated switchgear, GIS. The 110 kV gas-insulated switchgear is an advanced type of metal-enclosed switchgear that uses sulfur hexafluoride SS. This high-voltage equipment is designed with a three-phase common box structure, which includes several key components such as circuit breakers, disconnect switches, current transformers, circuit breaker operating mechanisms, box voltage transformers, surge arresters, and other essential elements like bushings or cable terminations. The circuit breaker is one of the most important components in GIS equipment and plays a crucial role in power transmission and transformation lines. As a vital control and protection device for power systems, the circuit breaker adopts a unique self-energy arc extinguishing principle with the assistance of thermal expansion and blowing. This innovative design allows it not only to successfully interrupt standard short-circuit faults, but also effectively deal with other types of currents, such as wet cloth faults, static area faults, and currents from capacitor banks and reactors. A three-position disconnector is another important feature integrated into the GIS module, which combines a disconnect switch and a grounding switch for maintenance purposes. This disconnector enables three different operating conditions: conductive, isolated, and grounded. Moreover, the grounding switch can be safely isolated from the enclosure. When adjustment and testing work of relay protection is required, the dynamic contact of the grounding switch can be electrically connected to the main circuit conductor of the GIS from the outside, significantly facilitating the testing process. The current transformer is a critical component in GIS, responsible for measuring current and providing overcurrent protection. The current transformers used in GIS are designed with a three-phase enclosed ring-type structure. The primary winding functions as the main circuit conductor, while the secondary winding is wound on a toroidal iron core. There is a flat ground between the main conductor and the secondary winding. The lead-out wires of the secondary winding are guided through an epoxy-sealed terminal board to an external bushing. The bushing acts as a connecting interface between the GI and the external world. As the three-phase common box type GIS body transitions from the bushing to the external phases, a surge arrestor is employed in the GI equipment to limit overvoltages and protect the power system. An online monitoring device is installed on the associated box of the surge arrestor, enabling the recording of the number of operations and the current during operation. Additionally, a voltage transformer is utilized for voltage measurement and system protection in the power system. During operation, it is crucial to strictly avoid short-circuiting on the secondary side, as it may cause significant damage to the voltage transformer due to the generation of high currents. Finally, an on-site control cabinet serves as a centralized control screen for monitoring and controlling the GIS equipment. It is used to connect the analog main control room to the interval and various components within the interval. This control cabinet allows for functions such as remote control, state display, electrical measurement, and other necessary operations.